Hello everyone. Last class we have discussed about concept of energy and coenergy in electromechanical system. We have seen that in case of nonlinear system, coenergy is greater than energy. At the same time, we have seen that if the air gap length is reduced, then the hysteresis graph becomes nonlinear. Today I will discuss about concept of coenergy. At the same time, I will discuss here that how the concept is useful in finding the torque and force in electromechanical system. So let's start. This circuit is already discussed in last class. This side is electrical input, then this one is your magnetic system. This is the movable portion of the system. This is the fixed part. Number of turns are wound on a magnetic material to magnetize it. Now this will become electromagnet when current will pass through the coil. Now this electromagnet will try to attract this magnetic material towards itself against this spring force, and the spring is connected to a supporting structure. This is your air gap length. Now if the current is not sufficient or the magnetic field strength is not enough to attract this material, then this magnetic material remains stationary. That means air gap length remains constant. But further, if this current is increased, then this strength of this electromagnet increases, and at a particular moment, this force is sufficient to attract this material towards this electromagnet, then it will move in this direction. Now, when movement is there, then only we can say there is a mechanical output across the system. When movement is zero or the magnetic material is stationary, then mechanical output is zero. So in that case, we have seen that whatever electrical input energy we are giving, that remains stored in the magnetic field. But if the movement occurs, then some amount of electrical energy is also converted to mechanical energy. So that mechanical output is nothing but force into the displacement. Force into displacement is equal to mechanical output power. So today we will discuss this portion. So to understand this one, let's focus on this graph. This is your current characteristics. This one also current characteristics, but at position x is equal to x2. So this is initial condition x is equal to x1. Now this is your current axis. This one psi, or the flux linked with the coil at this position. Now when the flux linked with the coil increases, or you can say that electrical input energy is increased, then this stored magnetic field will increase. At the same time, this electromagnetic strength will increase and the movement will occur. At the initial position, from the initial position x is equal to x1 to x is equal to x2, we will assume that movement has occurred. Now as soon as there is a movement in this magnetic material, then the length of this air gap reduces, and when the length of air gap reduces, then the current characteristics or the magnetic characteristics of the system becomes more nonlinear. So from x is equal to x1, the air gap length is, we can assume it is Lg. Then at x is equal to x2, the air gap length is now further reduced. As the air gap length is reduced, so the system becomes much more non-linear. So what happens here in this case, last class also we have discussed that this portion is energy and this portion is your coenergy. So when the movement occurs, then there is an increase in coenergy. So whatever increase in coenergy is there, that is equivalent to our mechanical output. So this we will discuss mathematically in this case. So you can see here that x is equal to x1 is the initial position of the moving system, and x is equal to x2 is the final position, or you can say in a small interval dt this has happened. Now during this period, current is assumed constant. Now the reason behind it, we can say that electrical system is too much faster than mechanical system. That means time constant of the electrical system is very low compared to the time constant of the mechanical system. So the movement is very slow. So we can say that there is no significant change in the current for a small interval dx, or you can say a small interval dt, or a small displacement dx. So the current can be assumed to be constant. So our assumption here is that current is constant, but movement has occurred from x1 to x2, and the flux linked with the coil changes from psi1 to psi2. And here also we have discussed that with the increase in air gap length, the current characteristics or the magnetization characteristics becomes linear. With the decrease in air gap length, that means when movement occurs, then the air gap length reduces and the current characteristics becomes non-linear. So here let's analyze these things mathematically, and we will obtain the expression of force with the help of coenergy. So the first assumption, the current remains same at both positions, as it is assumed that the movement is slow. So increase in input energy dW is equal to integration EI dt, and the flux changes from psi1 to psi2. This is psi1 and this is your psi2. So psi1 at position x is equal to x1, psi2 at position x is equal to x2. So dW is equal to integration psi1 to psi2 I d psi, and this is equal to area ABCD. So this area is increase in electrical input energy. Now dWf is equal to increase in stored magnetic field energy, and that is equal to, at position A, the stored magnetic field energy is OAD. At position x is equal to x2, the stored magnetic field energy is OBC. So we can say the increase in stored magnetic field energy is area OBC minus area OAD. From equation 1 we know that electrical input is equal to mechanical output plus increase in magnetic field energy. So here we can write dWm, that means increase in mechanical output energy, is equal to increase in electrical input energy minus increase in stored field energy. So dWe already we have obtained ABCD, this area, plus dWf we have obtained area OBC minus area OAD. Just substitute here. So area ABCD plus area OAD minus area OBC. So you see area, this area is your dWe. Now plus area OAD. So area OAD. So this becomes OABC. So this complete area becomes this portion, area ABCD plus area OAD minus of area OBC. So area OBC we have to subtract, then net it remains this hashed portion, this one, and that is OAB. So area OAB is nothing but increase in mechanical output energy. So if the motion has occurred under constant current, the mechanical work done is represented by the shaded area, which is increase in coenergy. So it is nothing but increase in coenergy. So if Fm is the mechanical force causing the displacement dx, then Fm into dx is equal to dWm, and that is equal to nothing but increase in coenergy. So this coenergy is very much helpful in finding the mechanical output power, or you can say the force developed by the mechanical system. Once you have got this mechanical output power, then output power is equal to torque into speed. From there we can find the torque of the system also. So we can say, though coenergy has no physical significance, but it is helpful in finding the force and torque developed by the mechanical system. Okay, so today we have discussed about energy, coenergy, then we have found out the expression of force, mechanical output power with the help of coenergy, and understood that Though coenergy has no physical significance, but it is helpful in finding the equation for force, torque of the mechanical system. So more about this we will discuss as the time passes, and we will discuss in DC motor drives and induction motor drives. Thank you.